Test. Tes.
Tes, halo, bisa dimulai?
Ya, bisa. Suara saya terdengar jelas ya, Pak ya?
Ya, terdengar jelas.
Oke.
Ya, jelas.
Kalau begitu, selamat siang untuk kepada para Bapak dan Ibu. Pada hari ini saya Deborah dari PT SARTOTECH Indonesia akan memberikan webinar terkait data integrity. Kali ini presentasi akan dibawakan oleh Mr. Dylan Chan selaku dari Pro Spesialis dari Sartorius. Kalau begitu kita langsung mulai saja. Nanti jika ada pertanyaan, nanti bisa di akhir dari sesi presentasinya ya.
Dia ngomong nggak?
Otak gue kayak kebagi. Otak gue kayak kebagi.
Okay, Mr. Dylan, can we start right now?
Yes, can you hear me?
Yes, I clearly
Okay.
I hear you clearly.
Yeah, thank you for your time. My name is Dylan. I need your help to mute yourself if you are not asking questions. As Deborah mentioned just now, you can post your question number one later when you can ask directly, or number two, you can post it in the chat box. So again, thank you and welcome to today's technical seminar. We are from PT SARTOTECH Indonesia. So I myself, I'm based in Kuala Lumpur, representing Sartorius, Malaysia. So today's topic is data integrity in GXP environment with Sartorius Cubis II. So Cubis II is the naming of our new product line. We call it Cubis II. GXP, it could be GMP, it could be GLP. So normally this lab product, we're going to use more on the so-called the GLP side. We have to obey the time very, very strictly. We are given only 45 minutes. So yes, major requirements and stakeholders for laboratory instrument. So nowadays, basically, the customers, let's say, or the user in the lab, basically, what are they looking for? So number one, of course, they are looking for trusted results. Okay, this is the end of the end product, or maybe the intention of their test, so on and so forth. And then of course at the same time they hope that they can have let's say efficient work, how the instrument can support them when they performing that job or doing the test in the lab. From the so-called the IT perspective wise, so IT will ask how can this instrument be integrated into my IT structure. So how this instrument will behave when I put into my network, for example. And then for another, let's say for manager's point of view, maybe she or he will think of data integrity aspect. Does the instrument needs the company's in terms of data data compliance, policy and so on and so forth. So this will be the one that holistically, they will put on the whole picture, saying that what will be the requirement for, let's say, modern laboratory instrument, for example, a laboratory weighing balance. So these are the things that, as I mentioned, people are looking for data integrity, for example, integrations of IT, into the network, how efficient the balance or maybe the instrument will work. At the end of the day, how can all this, translate into a trusted results? Okay, so this in terms of compliance, so this will be the screen, that you can have, when you have this Cubis II in the lab. So as you can see, a lot of red color, error message popping up from the so-called the status center here. So you have to deal with this error message, and then when we look at the center, also there's an indication or warning saying that the balance is not level, so on and so forth. So you can have a glance at what is the balance currently compliant to all the requirements that you have reset. So basically, as I mentioned, nowadays people talking about correct data transportation or translation into, let's say, to comply into their GLP or GMP quality systems. Okay, so what will be the consequences if we or the customer do not have this data correctly, let's say, transfer to the network? So, for example, inaccurate data leads us to wrong decision. If the data is wrongly translate, let's say you get 10 gram when you translate or you transport from your balance to network, it went, let's say, from 10 gram to 100 grams. So this inaccuracy definitely will lead you to a wrong decision being made. Or secondly, it will increase the risk of compromising data safety and quality. So this definitely the wrong data, not only, let's say, for example, the weighing data, let's say your HPLC data, when there's a wrongly translate data, in that kind of sense, of course, it will compromise the product safety and quality that you already promised to the public. And then, of course, when you have all this being, happens, let's say you have to recall back your product, definitely will have a negative impact on the product, in terms of costing. And more importantly, you are risking the patient health and safety. And then, of course, lastly, you are breaking the trust between the customer, the consumer, the patients, or maybe the company shareholders, and then ultimately lead to loss of brand reputation. The brand reputation is being tarnished because of, let's say, one or two incidents that you have wrongly made decision because of the wrongly translated, for example, the weighing data from balance to the network, for example. Okay, so one step back, when we talk about data integrity, what is data integrity, to be precise? Data integrity, basically data integrity meaning, data that we have recorded, we have to record it exactly as intended, and then the data remains the same as it was originally recorded. As I mentioned just now, you can see the data on the balance screen, for example, when it translate or transport out from the balance to a network, for example, or your LIMS system, it must be the same as well. So when you done with the processing of the data, in the LIMS, then you have to archive it also. That's why we said, the accuracy and validity of the data throughout the whole entire life cycle must be guaranteed. So that's why this is data integrity. Data integrity basically is not a new issue with computerized system, especially we are talking about, let's say, a higher end of instrument, for example, your HPLC. So this is not really a new thing, especially for those highly complex instruments. So the principles of data integrity applies equally to handwritten record as well, of course, including electronic data in modern days. So when we talk about data integrity, people tends to understand, or maybe relates only to modern data, electronic data, soft copy data. But actually, in reality, handwritten records, we use hand and paper to record the raw data, for example. It also must be data, integrity compliant. Okay, so these are the things that we have to look into it. As I mentioned, the whole picture, holistically, we have to get into a correct view. Electronic data and computerized system can increase the efficiency, of course, and reliability of data, because we reduce the interference or the manipulation for user, for example. Okay, so WHO data integrity guidance states that data integrity risks are higher when processes are manual or paper-based. So this is what we are expected. That's why a lot of customers are moving from manual, paper-based system or paper-based processes. They are upgrading to electronic system, for example, LIMS or maybe ELP. Okay, but our key question from customers is always related to how to achieve data integrity. So what will be the so-called the principle behind it? We have to observe or we have to obey. System and processes should be designed in a way that encourages compliance with the principles of data integrity. So that's the things that's why when you said, when you first thing first, when you want to achieve data integrity, so you must pick the system or processes that design already to comply that parts of, let's say, requirement. In this case is data integrity. So what will be the principle behind relating to data integrity? Simply, we put it as ALCOA principle, ALCOA. So A meaning attributable, legitimate, contemporaneous, original, and accurate. So you have to remember this short form, ALCOA principle should be part of the data life cycle documentations, and data integrity initiatives. So ALCOA principle must be implemented, let's say start from, as I mentioned, when you selecting instruments, for example, for your a lab balance, for example, okay, then you have to change or adapt your process to let's say to observe these ALCOA principles. We're going to look into one by one. This is ALCOA principle, follow the 5 principles of data integrity. A, again, attributable. So what will be the meaning behind? So who acquired the data? Okay, let's say, for example, who have done the test, who have transferred the data, perform or action or change the data record, and when. So who performed the action or change the data? So everything must be recorded by who and when. Legitimate data must be permanently recorded and be readable. Okay. C, contemporaneous. Was the data documented at the time of work was performed? Okay. So data must be performed on time. Data in terms of data documentation must be performed on time. You have set a process that, let's say, the archiving must be done, let's say, for example, within 3 or 4 days, for example. And then you must print out the hard copy, small tickets, when you get the result immediately. O is original. Is the data original record or trusted certified copy? So this is to make sure there's no manipulations of copies or duplications. Accurate. So no errors or editing of the data without documentation. So when you want to edit the data, of course, we have to ask, who have done the process, who have altered the data, who have edited the data, when and why he or she need to edit the data. So all this must be documented. Okay, as I mentioned just now, in order for you to first step, go into data compliance, data integrity aspect. So you have to pick instruments that compliant, to this modern requirements. So what will be the criteria when you want to select let's say a modern lab instrument? For example, you want to buy a new balance. So what are the aspects that you are looking into it, before you decide? So a modern lab instruments must provide technical controls, okay, to automate processes as much as possible to support your needs, your control, to ensure data integrity, compliance issues are not created, so on and so forth. That's why I said the first thing first, when you want to, let's say, change the balance, for example, from an old system to a new system. So these are the things that you really have to look into it. Technical controls must be there, on the modern balance or modern instrument. So access control and user management must be there. So the second options or second aspect you have to look into it is e-signatures, electronic signatures, time synchronizations, a safe data transfer, and then don't forget about backup. Backup is very crucial nowadays because it's part of the data integrity compliance. And then of course we have other record, let's say, for example, alibi memory and auditor, also very, very important in terms of compliance to the data integrity requirement by the FDA. Okay, so when we say this, we have a pharma package that contains all these technical controls to support compliance with common regulation without additional software. This is our strength. As I said, in order for you to compliant, number one, you have to pick an instrument. So these are the technical controls you must have, or the instrument have, in order for you to be compliant. And then, of course, preferably without any additional software for you to comply into all this, data integrity. This is our strength, without additional software. We will look into data integrity violation, bit by bit. For example, we'll show you some warning letters. We will discuss this. What will be the technical controls to solve the problems. Data integrity issues features in more than 65% of all FDA warning letters in 2018. So meaning FDA is highly focused on data integrity nowadays. As we understand, in 2018. 10 letters, about 7 letters are issued because of data integrity issues. So it's very, very serious. FDA is looking into this issue very, very seriously. So for the past 3 or 4 years, topics and data integrity have been moving to the focus, as I mentioned, for FDA inspection. When officer from FDA comes into lab, nowadays they are looking for data and data integrities. issues. Example, what they have issued, via these warning letters, backdating of data. Okay, the customer changed data, today they change it back to last year, next a year before, so on and so forth, so that they can redo the test without valid reason. And then not documenting batch related activities. Okay, what else? Not following procedures. They are violating these data integrities. Transferring data incompletely. Maybe they only transfer 8 out of 10 data. Okay, data captured in loose sheets of paper, manual work, not properly documented, the paper is here and there, it's very, very messy. Missing or inefficiency of audit trail function in the instrument. Okay, so these are the examples of data integrity warning letters that issued by the FDA in the modern times nowadays. So basically, what you need, as I mentioned from the beginning, in order for you to be compliant, to this data integrity, so you must adopt a modern laboratory instruments that can help prevent all these, so-called deficiencies, all these errors. Okay. So we will look into some of the findings. For example, this topic is related to logins to accounts. Okay, we say personal login accounts to ensure traceability here. So what are the findings from, let's say, FDA with the FDA warning letter 320/1736? So what are the issue highlighted by FDA? So what I've written here is your quality control analyst use a shared account to access HPLC systems. This shared account allowed analysts without traceability to change the date, setting of the computer, to modify file names, and to delete the original HPLC data. So these are things that highlighted. Shared accounts allow analysts without traceability. So these are things that we need to prevent. So what will be the solution from let's say from us, from Sartorius? So our modern balance required the setup of username, link into an individual, meaning every individual in the lab must have an accounts on the balance. And then the system must support strong password rules. You have to set rules for your password, similar to your banking, let's say, website. Lock users out after 3 to 5 failed password attempts. This is similar to our smartphone. If the user not authorized user try to log into the balance, for example. So after 3 or 5 attempts, the balance will locked. Okay, for security reasons. You can set, how many attempts, related to these violations. No system access without login, meaning the customer or the user must log into one account in order for them to start working on the balance, for example. And then inactivities, we can set, automatic logout after inactivity. You can set maybe 5 minutes or maybe 10 minutes. So the accounts will be automatic lockout. I mean, the user will be automatic lockout. In terms of optimized solution, you can always integrate the balance or the instrument into your company's domain to use the centralized user password management systems. How this work is basically we will connect, let's say, the Cubis II put into your Windows network, for example, if your company is using Windows. So Windows, the user, other words, the user can use their Windows login and password to log into the balance. Okay, so this can be done without additional software from us. This is already standard on the Cubis II. So why we need to have this, let's say, using Windows login into the accounts of the balance? So basically, by doing that, the balance is automatically complied to your password policy, for example. If you have, let's say, a policy of, let's say, the user need to change the password every 3 months, then will follow that rules. And then second findings, we have some issue with the role management. Okay, basically related to access control as well. What are the findings? Our reviews or audit trail data reveal that your analyst manipulated the date and time again. okay, on the HPLC, and then setting the clock back and repeating analysis for undocumented reason. So by having this access control, we will segregate the duties. Let's say, for example, administrators, guest operators, and service. Okay, you can always add those users that you require. Let's say a supervisor or analyst one, analyst two, level one, level two, level three, depending on your requirements. And then individual roles for configuration and operative work will be defined. So let's say as operators can only perform the weighing, they cannot go into the setting menu, so they cannot change the date and time. Okay, a user account should only have one role. So if let's say customer A is assigned with the operator role, so meaning that's the only things that he can do. He can do. So these are the limitations. In terms of time synchronization, so we can set, put it on auto mode. So basically, we'll prevent manual changing of time on the balance. Okay, so if let's say changes is logged, it's always logged into the audit trail. So these are the functions that we propose. Okay, audit trail is another crucial elements in the data integrity. So what are the findings from FDA, for example? So no audit trail function was enabled for the test folders. Okay, so what types of injection were made, who made them, all those are not documented. FDA issued a warning letter 3/20/15/08. So meaning we have to activate the audit trail. Okay, for example, our balance, you have to activate the audit trail function in order for you to document all these incidents or events. Okay, so all the events will be recorded with exact username, date, and time. The event must be documented in natural language, no system codes, so that normal people, human can read. It is required that audit trails are reviewed regularly. So depending on your strategy, you have to have a backups strategy or review strategy on this audit trail, depending on your company policy. And then preferably, the audit trail must be easily sorted, filtered and export, so that again, this thing can be backed up. So again, audit trail is the things that you must have in your next purchase of the instruments. Electronic signatures for trusted records. What are the FDA findings? Okay, in these letters, particular letters, the FDA mentioned laboratory record failed to include signatures. Okay, so modern instrument, you have to have record being appropriately signed or credentialed by the individual, because the user already logged in into their own account. So every work, every result will bear their name. For example, this we have highlighted here. The report was created by Weber. Weber is the user and signed with the electronic signatures. So electronic signature strictly forced for every record to ensure that this is done and the signatures is trustworthy. So how this electronic signature works on Cubis II is basically, before you send out the data, for example, you want to print the data out by using the printer. The balance will ask for your password. So once you key in the password, meaning you have signed, you have read the data, and then you have read the report. So that's the reason you put in your so-called signature or password. So everything will bear your name. The report will have your name printed out as indicated here. Okay, so electronic signatures are only accepted with personalized accounts, as I mentioned. Once the user log into their own accounts, everything will be documented, including the reports, and of course, comes with strict authentications. The before you print out, they will ask you for, let's say, your password. Safe data handling. So this is related to how the customers handle the data. For example, backup. So what FDA finds, these customers, they did not back up the data sufficiently. Okay, so you discovered, investigate at the end of the inspection, you told our investigators that you discovered that the database usage logs audit trails had been deleted from your high accuracy particle counters instrument. So a big problem here. So audit trails, usage log database has been deleted. So in modern requirements, according to FDA requirement, it should not be possible to delete data on instruments. This is their way moving forwards. Okay, their principles now. Invalid records may only be marked as such together with the reason. Okay, so as you can see here, our balance, once you highlighted a certain reading, they will ask you, will this indicate, are you going to flag the values at invalid, for example? If yes, so everything will be documented. They will ask you what's the reason you raise it as invalid. Okay, so GMP relevant data must be backed up, as I mentioned earlier. So you have to set up your own strategy in terms of backup. Okay, backup must be done to an external medium regularly. And then the optimized way is actually required automations. So you have to program, let's say, the balance to auto backup to your network drive every day or every night or every week, depending on your requirements. So our Cubis II have this function. Everything will be automated to reduce the stress that you have to, let's say, manually performing a similar task or the same task. Everything will be automated. Use only the standard file formats so that you can read in, let's say, up to 30 years. Okay, standard formats, it could be PDF. Yeah, PDF is standard nowadays. So I think once you have PDF format, you are safe. All files should contain a checksum to be verified against manipulation as well. So data, everything should comes with a checksum to verify against each other so that you can prevent manipulations in futures. Okay. In terms of monitoring the system status, so what will be the requirement from the FDA? So FDA finds that these particular customers fail to monitor and investigate error signals generated by the computerized systems that you use for HPLC. Okay, these signals indicated that the loss or deletions of original CGMP analytical data. Our investigator observed that you attributed numerous incidents to power interruptions, connectivity problems, and instrument malfunction. So the customers in these particular letters, FDA find out that they cannot put up a so-called effective system monitoring systems. So what will be the one that, what will be the criteria, let's say, if you are looking for a modern instrument to prevent all these findings by FDA? So modern instruments like Cubis II must offer functions to monitor the system status. So this is the system status, from you can view from our Cubis II balance. Okay, errors should be logged for later investigation and review regularly. So for example, here there's a error message here, there's a warning message here. So everything must be logged, must be recorded. Messages should be in natural language, no cryptic error codes for easy troubleshooting. So everything will be in plain language, in other ways of saying this, there's no, let's say, for example, error code, there must be an easy, readable, understandable natural language. Okay. Again, these are the screen that the status center that you can expect from our Cubis II. So for example, the leveling is now a level, compared to the first pictures that I show you. So the auto leveling functions have been activated. So the leveling is back to normal. So in order for you to understand the whole picture, so what will be the so-called, in terms of summaries, how to ensure data integrity and minimize the risk for your organizations? Okay, as I mentioned, pick a correct instrument. So what will be the one that crucial for your selections of instrument? Okay, so you have to ensure all computer systems are 21 CFR Part 11 compliant. Okay, you have to have a role-based user management strategy on your instruments. For example, your balance. You have to implement audit trail function in the balance or in the instrument. You must activate it. Okay, you have to secure the records with limited system access. Okay, you have to have password. You have to have let's say user roles, user rights, so on and so forth. You have to have a backup strategy. You have to maintain a backup and recovery procedures. Okay, you have a design a quality management system with SOPs and logical control. Okay, Preferably, let's say if you want the SOP, let's say your SOP preparing a salt, for example, a chemical, for example, we can help you to put into the Cubis balance as well if you want. So every step will be show on the screen, then the user can just follow step by step. And then of course you have to put in logical control during the process. What will be the, let's say, acceptance criteria, 5% tolerance, for example. You have to train the users properly and maintain the training records, for example. Okay, and then of course you have to conduct internal audits to evaluate controls, procedures, so on and so forth. So by having this, basically you are safe, in terms of, let's say, data compliance, data integrity. So in terms of compliance, so you have to have several connectivity ports. Let's say, for example, you have to export out the data to network. Okay, or maybe you need to back up the, let's say, the audit trail via some ports here. So that's why we have this connectivity. Just briefly show what will be the options on our Cubis II. So you can connect to external media, let's say a USB sticks. You can put on here, the USB port. If you have some like classical instrument RS-232 also, we still have the solution. We have network port that is not shown here as well. Okay, so in terms of, let's say, connectivity trends, so what will be the next? So we are talking about Industrial 4.0. So in terms of lab also, we are highlighting the lab 4.0 as well. Okay, the trend is basically moving towards a centralized data storage for laboratory data, results, the raw data in software like LIMS or ELN. So people are moving towards the LIMS systems or the ELN systems, electronic laboratory notebook. The main advantages are basically all results will be available in one place for easy evaluations. So all the data, let's say, will be collected in one place. Okay, in the LIMS system, for example, for calculation, for report generation, for report backup, so on and so forth. And of course, this centralized systems is basically compliant in terms of data handling. As I said, from the data come in, you assign a barcode, then you perform the test, the result, and then you generate the reports, so on and so forth. So will be the whole life cycles. Another reason for us to go into LIMS is basically documentation in terms of, there's paperless documentation. So we use lesser paper, reducing the risk of losing the important records in our lab. Okay. But ironically, in the sense of, let's say, integrations of instrument into the LIMS, currently we are facing a huge challenge. Okay, the reason being is number one, there's no standardized interfaces for integration. So people are using, let's say, LAN port, people are using USB-C port, people are using Wi-Fi, for example. So there's no standardized interfaces for integrations. But LAN, I think we are moving towards more and more to the LAN cable, the network cable, more and more. So to ensure, the better connectivities. But at the end of the day, we're still giving a lot of interfaces for integrations, in terms of, let's say, another challenge when we want to integrate our instrument to the LIMS system is actually we are having difficulty to transfer all the GMP relevant data onto, let's say, a LIMS systems. So not only the measurement result, must be transported out from the balance or from the HPLC. So basically, we need to transport out those metadata, audit trail, calibration log, so on and so forth. All those data are very, very important for you to be compliant to the whole data integrity. So we must not forget all this as well, especially the metadata, the data behind the checksum files, so on and so forth. Okay, another huge challenge is basically it does not fit into the existing IT landscape. So some of customers, they are on the higher end side, they want to use a Windows password to log in, so on and so forth. But some starter company, maybe they say, we do not have that kind of system implemented yet. So there's a lot of variation going on, when we want to connect our instruments to the LIMS systems. Okay, but as I mentioned, we already tell you, you know, what are the aspect or what are the criteria you have to look into it, you know, before you pick an instrument for your future usage in the lab. So a laboratory instrument must be future proof. So this is a keyword, future proof, to meet the current and the future connectivity requirements, because more and more requirements will be issued out, let's say from FDA or from BPOM, for example, from the Indonesian authority. So we do not know yet. So pick instruments that really, you know, they can offer you a future-proof solutions without, you know, further investing in futures. Okay. Documentations, in terms of, let's say, the current what we are doing, let's say a very classical way, we have a printout, a small printout, handwritten signatures and corrections. So if you have something like you want to correct here, so no way that you can document it properly. What you can do, you just cross it on the papers without valid, you know, kind of a process and so on and so forth. So another concern is how to digitize all these hard copies. Okay, so by having this LIMS or ELN system, basically you still have a lot of variation in terms of, let's say, as I mentioned, how we integrate our instrument to the LIMS system. So now we can use serial data transfer, as I mentioned. You know, you can have, let's say, a LAN transfer. You can use USB port. You know, how safe data will be transferred out. You know, will this include all metadata required? Also, is another question. So another aspect is the software itself. You know, by having, let's say, instrument connect to the LIMS systems, you know, does the instrument itself, you know, need you to buy additional middleware or software? So if they are requiring you to buy a middleware, a software for you to connect, let's say, a balance to a LIMS system, so of course you have to think about the software as well, how to maintain the software, how to validate the software, you know, the validation efforts, the cost, maintenance, so on and so forth, how complex it will be, you know, so on and so forth. All this you have to take into consideration. That's why, as I mentioned earlier, you know, try to pick a system that comes, you know, standard with all those features to enable you to be compliant. You know, don't pick system that, you know, you have to buy additional software, so on and so forth. Future-proof options from in terms of, let's say, a modern instrument should have. Okay, so instruments being said, you know, is future-proof. You must have support a wide range of connectivity options. As I mentioned, you can cover a LAN connectivity, Wi-Fi, a USB or USB-C port. You know, our balance also comes with USB-C port, or the classical RS-232, the serial port. The interface and protocol should be based on standard IT protocol for easy integrations. So pick those protocols that you know, standard into modern IT protocols. That's why you need to have several standard protocols built into the system. To ensure data integrity, the transfer should be based on encrypted and secure protocols such as HTTPS. So this is a modern so-called requirements when you have to transfer, let's say, a file to your network. So these are the standard being used now, HTTPS. Okay, secured way. REST web services offer an easy way to integrate devices bi-directional into LIMS or ELN systems. So this will be the so-called the IT language, you know, what kind of protocol you would like to have, you know, when you want to, let's say, integrate a balance, for example, to your ELN or the LIMS system. Okay, so this will be the so-called classical thermal transfer printer. You get a ticket from out of it. Let's say if you want to have a data transfer out, let's say to a LIMS system, to a file, a server, so you can have all these options, being offered into your choice. I mean, you must look for instruments that comes already with this. SMB, for example, IPP, HTTPS, FTPS, REST web services, and all, so on and so forth. So please, again, look for instruments that already comes with this protocol, without having add more software for you to integrate your instrument to the LIMS system. Okay, so we'll demonstrate to you, what will be the ideal solution. Let's say if you have a Cubis II balance in the lab, we are focusing on paperless weighing with Cubis II. So full lab system integration with Cubis II and STARLIMS. So we have an official partnership with STARLIMS. So for users who have interested in STARLIMS, definitely we can provide you with more detail. We already have a specific connectors. So what will be the normal process? Let's say a customer receives samples. Okay, so electronic sample management, we will assign, let's say, a numbering onto the sample. For example, in this case, we will have a barcode, and then of course we will have these automatic identifications of samples by reaching, let's say, when the sample reaches the Cubis II balance. So the balance can have integrated barcode scanner as well. So the customer do not need to manually key in this group of, these strings of code, very time wasting and so on and so forth. So we have a barcode system that can be integrated into the balance. So once scanned, the data will be recorded, including the metadata. So after the weighing process, for example, the result will be generated. So the data will be transferring out from the Ethernet. Okay, so this is a normal process. For example, in this example that we put up, we are weighing before and after. So you can see the example here. Weight before is how much, weight after is how much. So the weight loss is how much. Okay, so when you start the weighing process, this is what you can expect on the screen, on the balance screen. So this is the one that you key in your ID, sample ID. If you do not want to type, as I mentioned, you can always use this barcode scanner. So already have this protocol, you on the screen, the user can just follow. Okay, and then this will be the process. So after the weighing process, of course, you get the data. Before is 300 grams, for example. After is 116 grams. So the weight loss will be such and so on and so forth. So everything will be calculated, in the LIMS system. Okay. So this will be the overall, what we're going to propose. Let's say if you are integrating, let's say a balance into the lab. So moving forward, paperless. Okay, lab. So for scientists in R&D and analytical laboratory, mostly we need instruments that are reliable, that can generate reliable lab weighing results. The Cubis II from Sartorius is a completely configurable, high-performance portfolios of balance hardware and software, okay, that will align with your unique demands and compliance requirements to maximize operational efficiency and experimental outcome. So this will be the one that we are highlighting, the one that I mentioned to you, all the criteria, technical control, remember? So our Cubis II already comes with it, without additional software. This will be the solution from Sartorius. So by mentioning this, we would like to thank your time for your participation as well. This is the end of the presentation. I can be connected via the details here. If you want to connect to me, you can always email me or my partners in Indonesia. So we'll move to the Q&A session.
Thank you Dylan for the presentation. Untuk Bapak dan Ibu, dikarenakan waktunya sudah mau habis, kami mohon maaf untuk Q&A session sepertinya akan tidak bisa dilanjutkan. Nanti akan recording ini akan kami kirim by email, dan jika nanti ke depannya ada diskusi lebih lanjut, kita bisa arrange schedule di meeting schedule di event digital business networking ini di hari ke depan, atau nanti akan kita bisa diskusi by email juga nanti. Mohon maaf sebelumnya karena ada keterbatasannya waktu. Mungkin dari kami sampai di sini dulu. Sekali lagi kami ucapkan terima kasih atas waktunya.